Algebra 1, Scientific Notation. What is scientific notation? Well, scientific notation is a number written as the product of two factors in the form of a times 10 to the nth value. Now n, the exponent, will be an integer, and the a will be equal to or greater than 1 and less than 10. Here are some examples of scientific notation. Notice that the first value in each case is greater than or equal to 1 and less than 10. And then we have a times 10 to an exponent, and the exponent in each case is an integer, so it's a positive or negative number. Here's some non-examples as well. This number is 56. That is larger than 10, so this is not scientific notation. This number is 0.84, 84 hundredths. It's smaller than 1. And our first digit must be equal to or greater than 1 and less than 10. On this one, can you see what's wrong? You are correct. The number in front is larger than 10. Now, converting from scientific notation to standard, I'm going to show you the long version, and then I'm going to show you the shortcut. First, you need to realize that this is 1.55 times 10 to the 6. So this is what this actually represents. Now, if you multiply that, you're going to take this 1.55 and you're going to move this decimal point 1, 2, 3, 4, 5, 6. That's the short version. And we're going to add zeros. So 1.55 times a million is going to be 1,550,000. The next one, this is actually what's happening, is this is 2.3 times 1,000, because that's what 10 to the 3 is 1,000. But what's actually happening is you're taking this 2.3 and you're going to actually, by multiplying by 1,000, you're going to move the decimal 1, 2, 3 places. So your final answer is 2,300. Now, when it's a negative exponent, this is going to be 3, and the decimal point's right there. And you're multiplying by 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, that many. So what you're actually doing is you're going to move this decimal point. It's a negative value here, so we're going to move it this way 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to fill in that many zeros. So our answer will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that will be our answer. Okay, we have 1.2 times 0.001, which means that this is going to move the decimal point -3, so negative direction 1, 2, 3. So this is going to equal 0.0012. Do you kind of see the shortcut? And more importantly, do you understand what's actually happening? In scientific notation, you want your first digit to be equal to or greater than 1 and less than 10. So our first digit needs to be a 4 in the first case. So we're going to have 4.59. Now to get the decimal in this location right here, what do I need to multiply this by to get it back to the original number? Well, looking at this, I move the decimal from here. This is where it started. 1, 2, 3, 4, 5, 6, 7 places. So I multiplied this by 1, 2, 3, 4, 5, 6, 7 by 10 million. But instead of writing 10 million, because that doesn't really make our life any easier, we're going to make this 10 to the 7th power. Because again, I moved it 1, 2, 3, 4, 5, 6, 7 places to get the decimal point where the first digit is 1 or greater, but less than 10. In the second example, I'm going to want my decimal point right here. I'm going to want it to be 7.82. Now to get there, I need to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I'm going to multiply this by 10 to the 9. In the third one, I'm going to want my decimal point right here. I'm going to want it to be 9.85, because in that case, the first digit is 1 or greater, but less than 10. But in this case, I need to multiply it by a number that is smaller, because I'm going to move the decimal the other way. 1, 2, 3. So to get this problem back to the original, I need to multiply this by 10 to the negative 3. Can you try the next one? Well, I want it to be 3.25. So we move the decimal 1, 2, 3, 4, 5. So it's going to be 10 to the negative 5 because of the direction I'm moving the decimal. Now I kind of remember this by the positive numbers are going to make my original number bigger. The negative numbers are going to make my original, my standard notation, smaller. To multiply, divide, or find powers of numbers in scientific notation, we are going to use the properties of exponents. This is a typical problem in scientific notation. What we would do with this problem is we would use the commutative property and multiply 1.4 times 7.6. That's what you see here. And then we would multiply 10 to the fourth power times 10 to the third power. So you can see that 1.4 times 7.6 is 10.64 times 10. Now, we're going to do this more in class, but you're going to find out that when you multiply the bases, you add the exponents. So this is 10.64 times 10 to the 7th. Now, because this is in scientific notation, this problem is not done. And it is not done because your front digit has to be 1 or greater, but less than 10. And this is not less than 10. So I need to move the decimal point here. To do that, I'm moving that decimal point one place to the right, which is increasing my exponent by 1. So this would be my final answer. When dividing numbers that are in scientific notation, you divide it in two parts. You divide the front part, and then you divide the 10 raised to an exponent part. When we divide 1.2 by 4.8, you get 2.5. Now when you divide exponents, you subtract them. So it's minus 1 minus a negative 4. Well, of course, that becomes a positive. So you get 2.5 times 10 to the third power. Since our answer is already in scientific notation, we are done. We don't need to change anything. So that's our answer. In this case, we're raising a scientific notation problem to the third power. So we're going to raise each part to the third power. It's going to be applied to each part. Now 4 to the third power is 4 times 4 times 4, which is 64. And when you raise a power to a power, you multiply them. So this is times 10 to the negative 2 times 3. So this is 64 times 10 to the negative 6. Now, as you can see, this kind of looks like scientific notation, but it's really not there yet because our number is larger than 10. So we need to move the decimal point to make it 6.4. Since I moved it one place to the right, I'm going to increase this by 1. This is going to be times 10 to the negative 5. See you in class tomorrow.